All right. Hello and welcome. How is everybody? Are there any questions? Okay, I got some questions from Module 7 on my lab, so I will go over those questions. Please feel free to jump in for any questions, anything, okay? This module is about hypothesis test for two populations. One part of this topic is about two population proportions. The other is about two dependent population means, okay? So let's go over some questions. Question 2. Just want to move this over here. A survey of 700 adults from a certain region asked, "What do you buy from your mobile device?" The results indicated that 49% of females and 42% of males answered clothes. The sample size of males and females were not provided. Suppose that 400 females, 196 reported that they buy clothing from their mobile device, while 300 males, 126 reported that they buy clothing from their mobile device. Complete part A to D. Okay. So let's analyze this problem. This problem asks you to compare two proportions. One population is females, the other population is males. You want to compare the proportion of female with proportion of male with respect to buy clothing from their mobile device. Okay. So let's do the question. Question A. Is there evidence of a difference between males and females in the proportion who said they buy clothing from their mobile device at 0.01 level of significance? The question asks you to state the null and alternative hypothesis. Okay. Here we have keyword. When you see the difference, usually it is a two-tailed test. And when you look at H1, you should see not equal. So A, B, C, D, E, F. Which one has not equal in H1? Because this is a difference, means H1 has not equal sign. See, this one has H1 not equal. Okay. And do you have any other things showing that H1 is not equal? No. So answer C, question C is the correct answer. H0 said two population proportions are the same, and H1 said two population proportions are not the same. Okay. So any questions about H0 and H1? All right, so let's do the next one. Determine the value of test statistic. Okay, and also we are asked to calculate somewhere p-value here. Found p-value and found test statistic. You can use the formula to calculate test statistic, okay, to compare two population proportions. Or you can use the calculator. So here, I'm going to use this calculator, okay, to calculate test statistic. So if you have your calculator ready, you press F3 test. Proportion problem always use Z test. So you press F1, Z. And this is two population proportion. You press F4, 2P means two proportion. So again, I repeat, F3 test, F1 Z test, F4 two proportion. Okay. And then you have P1, P2. The calculator uses P1 represent population proportion, population 1 proportion. P2 represent population 2 proportion. You should be aware that in our textbook, when you do the calculation, we use P1 represent sample proportion, sample 1 proportion, and P2 represent sample 2 proportion. So don't be confused. Calculator use P1 represent population 1 proportion. Our textbook we use pi. See here, pi 1. Pi 1 represent population 1 proportion. So anyway, when you compare population 1 proportion with population 2 proportion, there are 3 simple on the bottom of your calculator, 3, okay? 3 simple. What are those 3? You have not equal, smaller, greater, okay? And you should really based on H1 because calculator is a H1 perspective, okay? So here you should select not equal, P1 not equal. So P1 not equal to P2, okay? So after that, X1 represent, in this X1 generally represent number of characteristics in sample 1, okay? Number of people having some characteristic. In this case, number of female by closing through their mobile device. So how many female by closing through mobile device? How many? How many female? See here, out of 400 females, 196 reported death by closing from their mobile device. So 196 is X1, 400 is N1. So on your calculator, X1, you type in 196, N1, 400. Okay. And the next asks you for X2 and N2. X2 represent number of male by closing from their mobile device. So number of males, 126 male by closing from mobile device. How many males in the sample? 300, okay? So X2 equal to 126, N2, 300. So this is all the numbers I type in, okay? All the numbers, and then you press EXE. And you are going to get the result, okay? I get, anyone want to share if you followed my steps? Just going to type in here.
I got 1.8389.
Fantastic, thank you so much. I agree with you. So I also got 1.8389. That is my Z value. So what did you get for P value?
For p-value, I got 0.0659.
Thank you so much for sharing, okay? So through this way, you get the p-value, you get the test statistic Z, okay? Any questions? How do you get the test statistic and the p-value to compare two population proportions? So we calculated test statistic. And next question asks we, critical value. What is the critical value? Critical value. Remember, we use the Z-test for population proportion. So the critical value, when you have alpha, where's my alpha? See, this is alpha. 0.01 is alpha. This is your alpha, okay? When you have alpha 0.01, so critical value is, anyone remember? If you don't remember, remind, how do I do critical value? Use calculator. Critical value, F5, distribution, F5, and then F1, normal distribution. After that, F3, inverse, okay? Inverse normal, and then data variable. Tail, this is a two-tailed test. See, this one here is a two-tailed test, not equal. H1 not equal means two-tailed test. Okay, so tail, you can select center. Okay, area, when you select, you could select left, right, that's fine. Because this is two-tailed, I would select center. So area is center because I have two tail. Left tail and right tail. So this center area is 99% because alpha is 0.01. Right, 99%. So when you select area, tail, center, area you put down 0.99. Sigma is 1, mu is 0. And then you press EXE. And you get two critical values. Okay, one is positive 5.756 or 2.576, and the other is negative 2.576. Okay, there are two critical values, positive, negative 2.576. Any questions for critical value? All right. And then state conclusion. State conclusion. Okay. So the conclusion is based on how do you select, draw conclusion. You have critical value 2.576, and your test statistics, see, we got from calculator, 1.8389. Okay. So this is your test statistic here. Okay. The absolute value of test statistics smaller than here. In other words, your test statistic is not in the rejection region. So your conclusion, do not reject H0. Okay, do not reject H0. So what is H0? This is H0, see? Population 1 proportion equal to population 2 proportion. Okay, that is the conclusion. So statistical conclusion, do not reject H0. Managerial conclusion, population 1 proportion is not significantly different from population 2 proportion. Okay, in other words, the two population proportions are similar, okay, at 0.05 level of significance. Okay. So that is the conclusion based on critical value method. And the next question is based on p-value method to draw a conclusion. We know we get p-value is here, 0.0659. This p-value greater than alpha, because alpha is 0.01 somewhere here. See, this is alpha here. Alpha is 0.01, and your p-value is 0.06. Okay, so see, p-value greater than alpha. When p-value greater than alpha, do not reject H0. Okay, so it is A, B, C, D. In this case, you should select the p-value is, oh, this is not ask you this asks you to interpret the p-value. Okay. So p-value is the probability of obtaining a result at least as extreme as the one obtained with this sample, given that the null hypothesis is true. That is the interpretation of p-value. The other interpretation people always say, p-value is the area corresponding to test statistic. So in this graph, where is p-value? So this is test statistic here, this point, see? This point is test statistic. P-value is the area corresponding to test statistic. So if this is test statistic, you draw a line, okay, straight line. And then this area, I use the blue color. This area plus, because of the symmetry, you have another test statistic, okay, here. So the total area in blue color represent the p-value. The blue area is the p-value. Okay, that is the interpretation. P-value is the area corresponding to test statistics. All right, any questions? So this is this question. And make sure you are very comfortable with this question. In this question, we go over two different methods. One method we call critical value method. You compare critical value with test statistic. In this example, critical value 2.576, test statistic 1.8389, test statistic smaller than critical value. So you conclude do not reject H0, means two populations are the same. Method 2, p-value method. You compare p-value with alpha. When p-value greater than alpha, do not reject H0. Conclude two population proportions are the same. Okay. Any questions? All right. So this is two population proportion problem. Let's do this one. Question 3. Suppose N1 equal to 80, X1 equal to 50. N2 80, X2 70. Part A, at 0.1 level of significance, is there evidence of significant difference between the two population proportions? Okay, so which one would you select? Any ideas?
Since it says difference, it would be C.
Excellent. You have keyword difference. You must select H1 that has not equal sign. Okay. As a review, because in your final exam, you have questions about H0, H1, you need to know why A is wrong, why B is wrong, why D is wrong. You need to know. Okay, so let's go over it. Why A is wrong? A said H0 pi 1 not equal to pi 2. H0 will never has equal sign. Remember this. Okay, H0 will never has equal sign. So what symbol H0 can use? H0 can use equal sign, that's fine. Okay. H0 can use smaller equal, it is okay. H0 use smaller equal. Or H0 use greater equal. But H0 will never use not equal. Okay. That's why A is wrong. The other reason A is wrong is that in H1, it said pi 1 equal to pi 2. It is used equal as H1. H1 will never use equal sign. H1 will never use this equal sign. So what symbol can H1 use? H1 can only use not equal. Okay, H1 use not equal, that's correct. Or H1 could use straight greater. Or H1 use straight smaller. H1 can only be one of these three possibilities. One of these three H1. Okay, so A wrong. Why B is wrong? B said H0, H smaller equal. H0 smaller equal, that's correct. See this H0 smaller equal, and then H1 greater, looks like great. See H1 greater, and they are paired together, looks like great. But question B does not apply to our situation. What is our situation? Our situation said difference. Okay. If I change our situation, I change my situation to, I change to this. At 0.1 level of significance, is there evidence that population 1 proportion greater than population 2 proportion? If I said that, B is the correct answer. I repeat my question. At 0.1 level of significance, is there evidence that population 1 proportion is greater than population 2 proportion? If this is my question, answer B is correct. Do you get the idea? When do you choose B? Okay. So we now C is the correct answer. Okay, so now let's go D. Why D is wrong? Okay. And D, H0 use this greater equal, fine. H1 use smaller, looks like good, and they're paired together. But answer D does not apply to our situation. Our situation said two population proportion different. D said population 1, D said, is there evidence population 1 proportion smaller than population 2 proportion? That is D. I repeat, D said at the 0.1 level of significance, is there evidence that population 1 proportion is smaller than population 2 proportion? If that is the question, you answer D. Okay. So any questions? Next question, ask you the test statistic, ask you for p-value. So you use a calculator, okay? So the starting point, you use F3 test. So you use F3 test. Not F1, you use F3 test, and then F1 Z test. After that, you select F4, 2 proportion. Okay, so F3, F1, F4. And then you enter the number. P1 you select not equal to P2. X1 is given. X1 you type in 50, N1 80, X2 70, N2 is 80. Okay. And you press EXE. I get Z negative 3.65. $6,515. And I also get p-value 0.00026. That is my p-value. Okay. So any questions? So next question I get. Okay, next question is about two population means. Two population means. So let's read the question. A study was conducted in which students were asked to estimate the number of calories in a cheeseburger. One group was asked to do this after thinking about a calorie-laden cheesecake. A second group was asked to do this after thinking about an organic fruit salad. The mean number of calories estimated was 792 for the group that thought about the cheesecake, and 916 for the group that thought about the organic fruit salad. Suppose that the study was based on a sample of 20 students in each group, and the standard deviation of number of calories estimated was 124 for people who thought about the cheesecake first, and 146 for people who thought about the organic fruit salad first. Compare question A and E. Okay, so this question compare two population means. Two population means. Okay, one population is about they think about calorie-laden cheesecake. The other population is they think about the organic fruit salad. Okay, so let's do question A. State the null and alternative hypothesis if you want to determine whether the mean estimated number of calories in the cheeseburger CY is lower for people who thought about the cheesecake first than for the people who thought about organic fruit salad first. This is the key word, lower than. Okay. And then let mu1 represent the number of calories estimated by the people who thought about the cheesecake first, and mu2 represent the mean number of calories estimated by people who thought about the organic fruit salad first. Okay. And choose A, B, C, D. Okay, which one is correct? Pay attention to this keyword is lower. Remember the keyword lower than, smaller than, apply to H1 perspective. So go through A, B, C, D. Which one has smaller than attached to H1? This one here. This one is smaller than. Okay, lower than, the same thing. Keyword smaller than, lower than, apply to H1 perspective. Similarly, keyword greater than, more than, also apply to H1 perspective. So the correct answer is B. Okay, and from this smaller than, we also know this is a left-tailed test. This is a left-tailed test. Okay. This is the picture of a left-tailed test. So any questions? B. In the context of this study, what is the meaning of type 1 error? What is meaning of type 1 error? And this one is tough because it is most students will feel very confusing, okay? I strongly suggest you draw a table for the definition of type 1 error and type 2 error. Okay, so remember the result of H0 . The result of H0 only have two results. It is either true or false. H0 is true or H0 is false. There is no third choice for H0. So this is on one hand, H0 has either true or false. On another hand, you have your decision. Okay, you have your decision. You have your decision. And your decision could reject H0. Okay, reject H0. When H0 is true, but you reject H0, you are making type 1 error. Okay, you are making type 1 error. This is the definition of type 1 error. Now, apply to this definition to our situation. H0 is true. What is H0? This is my H0. Okay. H0 is true, but you said H1 is true. That is type 1 error. Okay. So you said the mean for population 1 is lower than the mean for population 2. That is you said. When the fact is that population mu1 greater or equal to mu2, but you said mu1 smaller mu2. You are making type 1 mistake. So if you read carefully A, B, C, D, C is the correct answer. Okay, type 1 error is committed if one concludes that the mean is significantly lower. See, you are saying H1. You prefer, your conclusion is H1. You see, the mean is lower. Okay, when in fact it is not significantly lower. H0 said mu1 greater or equal to mu2 means not significantly lower. Any questions? So this is type 1 error. So next, type 2 error. What is type 2 error in this context? So let's go continue this table. What is the definition of type 2 error? When H0 is false, okay, and you do not reject H0, you are making type 2 error. When H0 is false, but you do not reject H0, okay. So in our situation, what is our situation? Always remember our situation is here. This is our situation. Okay, this is our test. Okay, you are making type 2 error. Means you are saying population mu1 greater or equal to population mu2. That is what you are saying. You are saying H0 is correct, when in fact H1 is correct. In this situation, you make type 2 error. Okay. So if you read A, B, C, D thoroughly, so question A is type 2 error. Okay. So you conclude is not significantly lower. You are saying H0 is correct, means not significantly lower. Okay. But in fact, it is significantly lower. Okay. So type 2 error. And under these two situations, you make the correct answer. When H0 is false, you reject H0, you are correct. And here, when H0 is correct, you do not reject. Again, you are correct. Okay. So any questions? And we haven't, this part D. Assume the population variance are not equal. Are not equal. At 0.05 level of significance, is there evidence that the mean estimated number of calories in the cheeseburger, okay, is lower than for people who thought about the cheesecake first than for people who thought about the organic fruit salad first? Found test statistic. Okay, and not equal. Population variance is not equal. So let's do that one. Again, pull out your calculator. Make sure you are at the home page. Okay, you are at the home page. You start with F3 test. F3 test. Okay. And then F2 T test. F2 T test. F2 again, 2 sample. So the starting point F3 test, F2 T test, F2 again represent 2 sample, 2S. After that, data variable, and then mu1, mu2, not equal or smaller or greater. The relationship between mu1 and mu2, you are asked to select not equal or smaller or greater. Remember those 3 symbols on the bottom of your calculator. Take H1 perspective. It take H1 perspective, okay? So you have to go back, where is my H1? See, this is your H1. This is your H1. So on your calculator, you have to select smaller. This is your H1, okay? So on your calculator, you select mu1 smaller than mu2. Mu1 smaller than mu2. Okay. And then x1 is this x1 bar, sample 1 mean. So where is my sample 1 mean? The mean number, See, it is this number here, 792. 792 is your x1, okay? 792 x1. Sx1, standard deviation of sample 1, see? Standard deviation of sample 1, 124. And N1, sample 1 size, 20. 20 is sample 1 size. Next, X2. X2 is 916. SX2, standard deviation is here, 146. And N2 is 20. Poured off. Last class we said poured on. When do you use poured on? When two population variants are the same, you use poured on. Here it is said population variants not the same. You have to say that poured off. Poured off. Okay. And then you press EXEK. Okay, so I'll write down here, poured off. This is important here, poured off. So after that, I get test statistic negative 2.8950. Negative 2.8950. And I also have p-value 0.00316. 0.00316. Okay. Any questions? So this is a test statistic and p-value. Use poured off. Okay. Last question. By the way, the question we just did, we have just done this one. It is 2 independent samples. Those two groups of people, they are independent with each other. Okay, so 2 independent sample test. Next question is dependent samples. Dependent here. Question 6. Okay. Let's read this question. 9 experts rated 2 brands of coffee in a taste testing experiment. A rating on a 7 scales, 1 extremely unpleasant, 7 extremely pleasant, is given for each of 4 characteristics: taste, aroma, richness, and authenticity. The accompanying data table contains the ratings accumulated over all 4 characteristics, complete A and D. So where is the data? The data is this table, okay? And in this table, how many people? In this table, 9 experts, 9 people. Each people will read 2 brands of products, brand A, brand B. And see, this is one person. One person will read brand A, brand B, and another person will read brand A, brand B product. And here, although you have 2 samples, sample 1 and sample 2, but those 2 samples are dependent because it is one person give product 1 rating, then product 2B rating. Did you see the difference? This is an example of matched sample t-test or dependent sample t-test. The example we did before, that is an independent sample. Those 2 samples independent. Okay, So be careful with dependent and independent. Okay, we are here. So this is an dependent because two sample data related to one person. Okay, they are matched samples. So this is original data. Once you have this original data, so what is the question here? Question A, at 0.05 level of significance, is there evidence of difference in the mean ratings between two brands? Okay. In our textbook, when you have dependent samples, the very first step, do I have the data here? No. The very first step, you calculate the difference between those two samples, D, okay? So you use 24 minus 25, so you get -1. 27 minus 27, 0. 17 minus 19, -2. Etc., etc. Last data, 19 minus 21, you get -2. Okay, so create a list. That is the capital D difference first. Okay, and then you enter this data into your calculator as one list. Not two lists, just one list. And this list is the difference between the original two samples. Is that clear? When you enter data into your calculator, you only enter one list, this list here, okay? So this is when you do the calculator later on. But now let's answer hypothesis test questions. I have to explain what is the mu D. See, A, B, C, D, everybody has mu D. What does mu D mean, okay? In order to answer what is mu D, I have to go back to this data. Remember I said, this list is the difference for sample. And remember, behind each sample, there is a population. This sample, you have 9 experts, okay? The population is all the experts in this field, okay? Do the tasting for this product, okay? And the average, and this, if you do the population, this difference will continue going on, okay? And the average of all this difference, that is the mu D. So do you understand what is the mu D? The average of population difference. Imagine this list is keep on going. You get the population difference. And the average of those number, okay, is mu D. So mu D, see the difference. The keyword difference means H1 select not equal. So the correct answer is A. If you have keyword difference, H1 not equal. Okay, so mu D not equal to 0, and mu D equal to 0. See, what is mu D? The difference between two population means. And next, you are asked what is the test statistic. Okay, to calculate test statistic, you have to enter all this data into a list, okay? And then you go this process. Suppose this is your list 1. So list 1 has data -1, 0, -2, keep on going. Last data -2, total you have 9 data. Okay, that is your list one. Suppose you enter the data in your list one. So what would you do next? You press F3 test. F3 test, and then F2 t-test. F2 t-test. After that, F1 one sample, because list one, just one data. Okay, so I repeat, F3, F1, F2, F1, and then data is list, not variable. For the data, you select list, and then list, okay, data is a list, and then mu, select not equal, mu 0, and mu 0 is 0. Okay, mu select not equal, and mu 0 is 0. See here. See, this is 0. This is mu 0. Mu 0 is 0. Okay. And the list is list 1. And after that, you press EXE. You will get a test statistic after this step. Okay. So this is, once you get a test statistic, you compare test statistic with a critical value. Critical value. And how do you do critical value? F5, F2, F3. You get the critical value for T. Okay. And then you can use critical value method. And the other way to draw conclusion is to use the p-value method. You can get p-value from calculator. You compare p-value with alpha. When p-value greater than alpha, do not reject H0. When p-value smaller than alpha, reject H0. Okay, so that is your conclusion. Okay, any questions? In summary, what we did in this module, we did hypothesis test for 2 populations, okay? We actually did 3 topics. One, we did 2 population proportion, okay? 2 population, we compare 2 population proportion. And second, we compare 2 independent sample t-test, independent sample t-test, and number 3, dependent sample test. Okay, dependent sample test. Dependent sample t-test has another name, matched samples. Okay, in each 1, 2, 3, you can use a critical value method, or you can use a p-value method. Okay. Any questions? All right. Let me see who are the participants here. All right. Thank you so much for your participation. I look forward to see you next class. Good night.
Thank you, Professor.
You're welcome.
Professor?
Yes.
I think I emailed you for a question, but I think I put the attachment, but the subject line, I think I put the module number probably wrong. I will resend it to you again tonight. I would really appreciate if you could go over it next Saturday, if possible.
Absolutely, yes.
Okay, yeah, I think I
also
got
question,
confused.
yes.
I think I got confused. I put the module number wrong. So what I'll do is I don't remember the module. I'll just attach the screenshot of the question. Is that like enough information, or do you want like the module number?
I prefer module number and also plus the screenshot.
Okay, sounds good. Okay, then I'll look for the module number then.
Okay, thank you so much.
Okay, thank you, Professor. Have a
You're
good
welcome.
weekend.
Bye-bye.